this lesson, we are going to learn how to draw a Lewis dot structure. Now, given our chemical formula, this is a carbonate with a net charge of 2-. So we have to take account of the minus charge or the positive charge. The first step is to find the total number of valence electrons from all the atoms as given in a chemical formula. In this case, we use this strategy based on the group number, and we look at the periodic table group number A only, and that number is also equal to the number of valence electrons. So here we have carbon, oxygen, and a 2-. What does that mean? In this chemical formula, there is only 1 carbon, and there are 3 oxygen because of that subscript there. So 1, 2, 3 oxygen. And that 2-, again, going back to the idea is that electrons are negative. So the only way an atom or a compound has a negative charge is that it has gain electron. So that 2- show that it has a gain 2 electron. What about when it's positive? When it's positive, you have to subtract electron, because the only way an atom or a compound become positively charged is that it has lost an electron. So negative, add electron, positive, subtract electron. Now going back to our periodic table, carbon is in group 4A, so therefore it has 4 valence electrons. Oxygen is in group 6A, so it has 6. 6 here, 6 there, and 6 there, and we're adding 2 more electrons. Now 2 plus 6, that gives us 10, and that gives us 6 plus 6 gives us 12, and then plus another 2, so give us a total of 24 electrons. The next step is to determine the arrangement of atoms, basically saying, hey, which atom is going to be in the center and which is going to be the surrounding atom. And we are looking at the least electronegative atoms is going to be in the center, but here's a shortcut. Usually by looking at the chemical formula itself, the element that's written first is usually the least electronegative, except for hydrogen. In most cases would be carbon. However, it would never be hydrogen. Hydrogen would never be the central atom, even though it is written first. So keep that in mind. In this case, carbon is written first. But if we don't know that and we want to look back at the electronegativity, going that way, electronegativity increase. Remember, fluorine is one of the most electronegative elements. Going down, we will have a decrease, which is the opposite of increase. So that is the trend for electronegativity. But in this case, we just look at the chemical formula, which is C. So we have carbon right in the middle. And where will we put the oxygen? Basically, even them out surrounding the carbon. And the next step is to make a single bond. Remember, a single bond consists of 2 electrons. One donated from one atom, the other one is being donated from another atom. In this case, we have 3 surrounding atoms, so we make a single bond between the central atom and each surrounding atom. So we make 3 single bonds. Now, each single bond consists of 2 electrons, a share between the 2 atoms. So therefore, we just use 2 for 6 electron total. And that gives us a total of 18 electrons left. So that is step 3. Step 4 is I need to make sure that all the atoms are stable, because the goal of sharing electron or making a chemical bond is to have an octet. The next step is adding remaining electrons to make sure all surrounding atoms and also the central atom, but we're adding the surrounding atom first to make sure they have an octet or 8 valence electrons. Except for hydrogen, only need 2 electrons to be stable. In this case, let's look at oxygen. Let's look at this oxygen first. Here it has 2 electrons already, so it needs a total of 6 more, give us a total of 8. But when we place electrons, we place them in pairs. Going back to the ideas of the orbital diagram, remember the boxes, we place electron in pair, one going up and one going down. The same thing for Lewis dot structure, so we place them in lone pair, that's what they call it. So here I would need 1 lone pair there, that gives us a total of 4, another lone pair gives 6, and another lone pair gives us 8. So I use 6 over here, and for this oxygen, it's the same thing. It has 2 from the single bond, and it needs 6 more. So again, lone pair, 1, 2, and 1, 2. And the same thing in this case, it has 2 and only 6 more. 1, 2, 1, 2, 1, 2. So all the oxygen atoms surrounding the central carbon has an octet. And we have used 6, 12, 18, give us a total of 0 left. Now, all the surrounding atoms are octet, except if we look at carbon, it only has 2, 4, 6. So what are we going to do? Here is a common strategy for it. All you have to do is make multiple bonds by moving the lone pair around. How does that work? Because when we have a double bond, it is now count as 4 electrons between the two atoms. And if we have a triple bond, it's count as 6. In this case, it has 2, 4, 6. So what we can do is we can take any of the lone pair, okay, from any of the surrounding atom and make a bond between them. So in this case, I'm going to take this one right here, okay, and I'm going to bring it down and make a bond right here. Now, that lone pair is gone, okay, because it has been used to make another bond between this central atom and that oxygen. And let's count if carbon now has an octet. So 2, 4, 6, 8. That gives carbon octet. What about this oxygen? 2, 4, 6, 8. And that's the beauty behind covalent compound. We can share electron, and that shared electron count for both atoms that's being shared. And what about this oxygen? It already has octet, and the same thing for that one. What does our final Lewis dot structure look like? We have carbon. Down here we have oxygen. And then to represent that has a net charge of -2, we use the bracket to represent 2-. So here we have carbonate Lewis dot structure with a 2- charge. Now let's try another compound where it doesn't have a charge at all. So in this case we have HCN. Okay, so this is the chemical formula for this compound. First we have to find the total number of valence electrons, which give us, we have 1 hydrogen, 1 carbon, and 1 nitrogen. Since there are no charge, because there's nothing up here, there's no superscript, so we say, hey, we're not going to add or subtract any electron from the total valence electron. So in this case we have hydrogens in group 1A, so it has 1, carbons in groups 4, so it has 4, nitrogens in group 5, so it has 5. And that gives us a total of 1 plus 4 plus 5, that gives us a total of 10 valence electrons. The next step is to determine the arrangement of atoms. So again, usually the element that's written first is going to be the one in the center, or often it's going to be carbon, but never hydrogen. In this case, hydrogen is written first, but again, it's never going to be in the central atom. Followed by the next element is carbon. So carbon again, if we see carbon is usually in the center. Now we have nitrogen. If we're not sure which one it is, we can compare their electronegativity. Going across is increased. So here's carbon and here's nitrogen. So therefore carbon is less electronegative than nitrogen. And therefore it is going to be in the center. Again, the least electronegative is going to be in the center. So we have C and N on this side and hydrogen on that side. That is step 2. The next step is to make single bond between the central atom and each surrounding atom. So I make 1 single bond there and make 1 single bond there. Then we are going to add the remaining electron to make sure all surrounding. Again, we focus the surrounding atom first, not the center atom, to have octet. Except for hydrogen, in this case, this one is octet already because it has 2 electrons. With the nitrogen, we need 2, so it needs 6 more. So again, we place them in a lone pair format because our orbital diagram is like this. One go up, one go down with 2 electrons. So we have 1 lone pair there, 1 there, 1 there, and 1 here. That gives us a total of 2, 4, 6. So we have used a total of how many electrons? Oh, we forgot to keep track of how much electron we use. In this case, we have 2, 4, 6, 8, 10. Oh, there you go. We used 10 electrons. Now we have 0 left. And the next thing we have to do is we have to make sure all the atoms has an octet. Hydrogen is, carbon of course not because it only has 2, but we don't worry about it yet. Then nitrogen, yes, it has an octet. So again, what is the trick to make sure that all the atom has an octet is by making multiple bonds, using the lone pair from the surrounding electron. Because when you make a double bond, this pair is going to be 4. When you make a triple bond, now it's shared by 6 electrons. So in this case, we have 2 4, so we need 2 more lone pair. And where's that lone pair going to be? It's going to come from the nitrogen. We're going to bring down here and make another pair right there. So we can erase that. Then we can use that one, and then we can bring this down here and make another one. So now that one's gone. So let's check. We have 2 4 6 8. Now that one is octet. We have 2 4 6 8. That one is octet. So there you go, and that's how you can manipulate the lone pair from the surrounding atom to make additional bonds so that the central atom can become octet as well. So our overall Lewis dot structure will be C with a triple bond N. Now let's try an example where a compound has a positive charge. In this case, we can look at ammonium NH4+. So again, the first step is to find the total number of valence electrons. In this case, we have N, H, 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 and that plus 1 indicates it has lost 1 electron, so we subtract 1. So nitrogen is in group 5A, so therefore it has 5. Hydrogen is in group 1A, so it has 1, 1, 1, 1. And we subtract 1. So 5 plus 1, 2, 3, and that one cancels each other out, so give us a total of 8 valence electrons to use. And the next step is to determine the arrangement of atoms. Of course, the least electronegative is going to be in the center, but we can just look at the chemical formula and to see which one is written first. In most cases, it's carbon, but never hydrogen. Well, in this case, it is nitrogen. So nitrogen is going to be in the center with 4 hydrogens surrounding the nitrogen. And then we just move on to the next step. We make a single bond using 2 electrons each. So we have 1, so it's 2 there, 2 there, and 2 there. So give us a total of 2, 4, 6, 8. Hey, we just used all 8 valence electrons, so now we have 0 left. And the last step is to check that make sure all the atom has a stable octet, except for hydrogen only need 2. In this case, hydrogen has 2 from that single bond, so all the hydrogen already octet. The only thing left is the nitrogen. So nitrogen 2, 4, 6, 8. Hey, it is also octet, so we're done. So that's easy. So here we have NH with a bracket of a positive. This bracket showing that hey, this whole entire compound or polyatomic ions function as a unit with a net charge of 1+.